Good morning everyone. Today we are discussing about another topic of second unit of the subject CBM 365 robotics in medicine, that is the Jacobian matrix. So after completing this presentation you must get a concept about the what is a Jacobian matrix. So, Jacobian means what? It is a mathematical tool that shows how the motion of a robot joins affect the motion of robot end effector at a particular moment of time. In simple words, it converts small joint moment or joint velocities into small moments or velocities of end effector. Because of robot's joint angle changes with time, the robot shape or geometry also changes. So the Jacobian changes with time as well. So, for example, in a 2 degrees of freedom robot, when the joint 1 rotates by its small angle, the resulting moment of point B can change depending on the robot current position and configuration. So, the Jacobian captures this relationship, explaining how all joint motion combine to produce the overall motion of a robot at any time. So, resulting motion of robot are depending on the geometry of the robot. So this figure shows simple robot arm in 3 represent position. In all case, all joint rotate at angle theta even though the joint moves the same and the end B moves in different direction in each position. First position B moves sideways. Second position B moves mostly up and down. Third position B moves in a slanted direction. The position of the robot is written using the equation. The equation shows how the output value y depend on input value, that is yi equal to fi of x1 x2 x3 up to xj, that is x is the input variables, fi is the input function, that is how output is calculated, and yi is the ith output variable. Assume we make a very small change in the output, so we take del yi, the differential equation of first output equal to del y1, that is dou f1 by dou x1 del x1 plus dou f1 by dou x1 del x2 plus etc. up to del ith term. The same idea applies for all output, that is del y2 del y3 up to del I. So we have the equations for del y1, del y2 and dou y1, dou y2 and dou yi. This equation gives the differential relationship between individual variables and functions. So Jacobian is a table of partial derivative. Each derivative tells how much the output change, that is the end effector position change when input change, that is join mode. So we get a final output as a matrix. So the first element dou y1 up to dou yi is the small change in the input. Dou f1 by x1 up to y, we have the Jacobian. The middle one is the Jacobian matrix. The middle one is the Jacobian matrix, and dou x1 dou x2 up to dou xj, that is the small change in the input, and the equation can be rewritten by the symbol form is the final equation. So this is the Jacobian matrix view. Hope all of you understood about the Jacobian matrix. That's all. Thank you.